طيب بسم الله الرحمن الرحيم. الحمد لله والصلاة والسلام على رسول الله. لأن الوقت ضيق فبنبدأ راسا. بس أبغى يعني أقول لكم إني اللي قررت إني أمر لكم على مسائل نحلها في شابتر 10 و5 و6 و7 في مسألتين، ولكن يمكن ما يسعفنا الوقت. المهم نبدأ بشابتر 10، وأفضل شيء على أساس نمر على القوانين وإحنا أنتم تشوفون الآن الشاشة صح؟
ايوه.
طيب بسم الله الرحمن الرحيم. نبدأ من هذه we'll start with this problem. A gas-filled balloon having a volume of 2.5 liter at 1.2 atmosphere and 20 degrees C is allowed to rise to atmosphere about 30 kilometers above the surface, where the temperature is minus 23 degrees C and the pressure is 3.00 times 10 to the power minus 3 atm respectively. Calculate the final volume of the balloon. أول سؤال, what is the question? What's the equation that we're going to use?
BVOT.
V1 over T1 equal to P2 V2 over T2. Everything is available here. This is V1, this is P1, this is T1, and this is T2, and this is P2. What's left?
V2.
Calculate it. Do it. Use your calculator and give me an answer quickly.
$853.
Exactly, 853, and that's the answer. It's available for you here. Yes, good. Next, a mixture of helium and neon gases is collected over water at 28 degrees C and 745 millimeter Hg. If the partial pressure of helium is 368 millimeter Hg, what is the partial pressure of neon? Can you do that?
Yes.
The pressure. So what we have here, we have helium, we have neon, and we have, of course, since there is vapor, this means there is water. Okay, the pressure of the helium is 368, which is this one. The pressure of the water is 28.3, which is here. Okay, we want the pressure of neon. Can you calculate it?
348.7.
How?
We by using B total is equal B1 plus B2 plus B3.
Exactly. The first thing you must calculate P total. How can you calculate P total? By applying
B1 plus
no,
B2.
no.
B1 initial.
We have
partial pressure for the neon plus partial pressure for the helium and partial pressure for what?
Okay, this is the problem. Okay. Okay, the total pressure is 748, mixture of helium and neon gases. The total pressure is 748. So this is 745. P total equal to what? P1 plus P2 plus P3. Okay, So if I want the P total is 745, how can I find the pressure of neon? Subtract this number from this number and this number. Is this clear?
Yes.
Which law is this? What's the name of the law?
Partial pressure, I think.
Dalton law of partial pressure. Okay, clear? Good. Next, and this is the correct answer. A sample of ammonia gas is completely decomposed to nitrogen and hydrogen gases over heated iron wall. If the total pressure is 666 millimeters G after the reaction, calculate the partial pressure of each gas. In here, you have to write first the equation. By the way, if it's in the exam, I'm not going to give you this equation. You have to write it yourself and then balance it. It's now, is it balanced now?
Yes.
It is balanced. Okay. And now the total pressure is 866. What's the pressure of nitrogen? What's the pressure of hydrogen? If this is completely decomposed, so nothing is left. This is completely decomposed. This means nothing is left. And we have only this gas and this gas. And this is the total pressure. What's the pressure of hydrogen only? And what's the pressure of nitrogen only? Can you help me? Okay, let me help you. If this pressure is X, what will be the pressure of hydrogen?
3x.
3x. Why? Because 3 mole to 1 mole, the ratio will be like this. All right? And so the P total is equal to what? 4x. Now, what's the pressure of hydrogen only? 3/4 times 866. And the pressure of nitrogen is 1/4 times 866. How easy? Is this clear?
Yes, it's clear.
Yes.
Good. These are the pressures that you calculated. Okay, good. A mixture of gases contain 0.31 mole CH4, 0.25 mole C2H5, and 0.29 mole C3H8. The total pressure is 1.5. Calculate the partial pressure of each component. Now, what's the relation that we're going to use? P of X is equal to what?
Pi over P total.
What's this drawing? What's this? X, not X. I'll call this one, just a second. Let's say that the pressure of CH4 equal to what? Equal this letter X, CH4 times the 1.50. What do we call this X?
A mole fraction.
Mole fraction, exactly. How can you calculate the mole fraction?
Partial
Or
or
divided.
First, you have to find what's NT, which is equal to what?
0.85.
0.31 plus 0.25 plus 0.29. Okay, what's the final?
0.85.
0.85. Good. Now, what's the pressure of CH4 only?
0.31 over
Exactly.
0.85.
0.85 times 1.50, and then you can calculate the pressure of each component like this. Is this clear?
Yes.
Okay, let's continue. If you calculate it, anybody do the calculation quickly. What's the answer?
It's 0.547.
Yeah, exactly. What's the pressure of C2H6? Quickly.
It's 0.441.
Okay, and these are the answers, the correct answers. You can see them. It's already written there, but I just want you to calculate it. Good. Okay, now the airbag in the car are inflated when collision trigger the explosive. Highly exothermic decomposition sodium azide. This is called sodium azide. Okay, it decomposes to give you sodium and nitrogen gas. A typical driver bag contains 50 grams of sodium azide. So this is 50 gram sodium azide. I want you to tell me how many moles is this? Calculate how many moles.
0.76.
0.76. How did you calculate?
69.
Somebody says 0. What?
769.
How did you calculate it? Divide this number 50 by what?
By the molar mass of sodium azide.
And 3 times nitrogen. Exactly. Good. This is 0.769 mole. If we have 0.769 mole of this one, how many mole of nitrogen we're going to make? You multiply this number by what?
By 3.
By 3 and divide by 2.
Exactly, which is, give me the answer.
1.15.
1.15 mole. Are you following with me? Good. Now, if I know the number of moles and I know the temperature and the atmosphere, what can I calculate?
Volume.
The volume. What's the name of this equation?
The equation of ideal gas.
Ideal gas law. Ideal gas law. Exactly. What's V equal to?
nRT over B.
Give me the final answer. Yes.
33.81.
33.81. Let's see if it's correct. I go solve it here. 33.92 according to my calculation. Can you see it? But that's okay, no problem. Good. So this is the ideal gas law, and we use it in such equation. Good. Calculate this question also. The chemical decomposition of glucose sugar with oxygen to give you this. Calculate the volume of CO2 produced at 37 degrees and 1 atmosphere when 10 grams, again, we have 10 grams of this one. Can you calculate the number of moles?
Yes.
Quickly give me answer.
0.056.
0.056 mole. I want everybody to share whether they say or not, but what will be the number of moles of CO2?
0.33.
0.33.
Exactly, so it's 6 times this number, right?
Yes.
But again, we're going to apply the same rule. We want to know, calculate the volume. How can you calculate the volume?
nRT over B.
P. You have P, you have T, temperature, and you have, of course, R is available in the periodic table, but what is R?
0.08206.
Oh, 206, fine, or 21, fine. Okay, very quickly, give me the final answer.
8.48.
What is it?
8.48.
8.48 liter. Who got the same answer?
Yes, me.
Good, great. This is the correct answer. It's available for you again. Here, exactly, good. Okay, calculate the pressure exerted by a column of mercury 70 centimeter high. Only. What's the pressure? What's the law that we're going to use?
HDG.
DG. What's H?
H the height.
Height, which is this one. But the unit must be what?
In meter.
Why? Because we're going to use SI unit. Okay, so you have to change this to meter. What's the answer? 0.70 meter. All right, good. The density of mercury is this number, 13.5951 gram per centimeter cube. I don't want it in gram centimeter cube. How do I want it?
Kilogram per meter cube.
Exactly, kilogram per meter cube. How can I change it? It's
Times by 1000.
0.5951 gram over centimeter cube times each 1000 grams equal to 1 kilogram, and I will change it to kilogram, and then each 100
cube.
1 million, okay, 10 to the power 6 centimeter cube is equal to 1 meter cube. Why 10 to the power 6? Because each meter is 100 centimeter. 100 times 100 times 100 is 1 million. What's the final answer then?
93357.
1.3.
No. 933.
Why? Cannot be 9.
No, 13.
15,500.
5951 times 10 to the power 3. Or 1.357, or is it 97? What is it? 59, 95 times 10 to the power 4. And now it is kilogram per meter cube. Okay, and we know the density. What's the density? It will be given to you, of course, but it is 9.80 meter over second square. Now calculate what's P.
So 93.
9.32 multiplied by 10 to the power 4.
Okay, maybe. What's the unit?
Pascal.
Yes. Now,
Pascal.
yes, when you do this, which is meter and so on and so on, this one is Pascal. You have to know this. And now, can you change it to atmosphere? So the answer is 9.33 times 10 to the power 4 Pascal. And then if you want to change it to atmosphere, you don't have to memorize the changing factor, but actually you can divide it by I forgot. Okay, I will give you the unit how to change it to, but the most important thing, when you do the calculation the way we did it in here, the answer is in Pascal. Okay, and then you can change it to atmosphere. I will give you the relation. It's actually 101 something.
101.325.
Exactly. It's actually, to change this one, you divide by 101.325.
Yes.
Yes.
This will give you atmosphere. Is this also clear?
Should we memorize it?
No, don't be. I don't know it. You can see I forgot it, but I know it's 101, but I don't know what's exactly. Don't memorize this number. Know how to transfer from Pascal to atmosphere. That's all. Okay, the volume of bubble. That's an interesting question. Start at the bottom of the lake. So we have a lake, and there is a small bubble here. It went all the way to here. This bubble from here to here. Okay, when it started here, the volume was V1. When it ended up here, the volume is 10 times the volume increase. Okay, the volume of a bubble that starts at the bottom of the lake at 4, so temperature was 4.55 degrees C. Okay, and the volume increased 10 times. So if this is V1, the volume here is what? 10 V1.
V1.
Okay, okay, and the surface where the temperature is, and the temperature here was 18.45 T2, and this T1. Good. Also, the pressure here P2 is equal to 0.965, and the pressure
You want the height. So when you find the first pressure,
yes, exactly. So we want to calculate P1 here. That's all what I wanted to calculate now. Can you calculate P1? What law we're going to apply?
V1 over T1.
P1 over T1 is equal to V2 P2 over T2. Everything is given to you here. Don't forget to change this to 10 V1. Okay? And the temperature change it. I wanted to calculate what's P1. Go ahead. Any answer?
9.18.
9.188. Exactly. That's a pressure down there at this bubble. And now now we want, he doesn't want this, he wants the height of the water. Can you calculate the height of the water? First, you calculate the height of the column of the water, which is this. What's the height? What's the pressure of the water here?
We should convert it to Pascal, right?
Just before it's actually P1 minus P2, right? Because this is the pressure of the column of the water, and this is the pressure of outside the air. So the pressure of the water is the difference between this number and this number. And what's the answer?
8.223.
223 atmosphere. Now, in order to do P equal to HDG, I have to change this to Pascal by multiplying by what? 101.325. Don't memorize this number. I'll give it to you. What's the answer? Who got the answer?
Doctor?
Yes.
What's the value of V?
Which B?
V1.
That's
Yes.
it. It's here.
9.118.
Exactly.
188.
Yes. From this calculation from here, which is P1, that's P1. I calculate P1. from this
Yes.
equation?
Doctor,
Yes.
is the height 0.085?
I do. Yes, let's finish with this question first. Is this clear يا شاب اللي سأل عن P1?
Yes, so with the number that we substitute instead of V in the equation.
No. This is a P1, the pressure at the bottom. And this is the pressure at the top.
Oh, okay.
What's the difference? Is the pressure of the water here, the column. So
Yes,
if you subtract this one minus this one, this will give you the pressure of the water. Clear?
Yes. Clear.
Very good. And that's 8.223. Now I change it to Pascal. Then, after I change it to Pascal, I apply which law? P equal to what?
H D G.
D G. And of course, change this to kilogram per meter cube. You have to change it to kilogram per meter cube. Okay?
It'll be 1,000.
No, the meter cube is 1,000 liter. It's 1 million milliliter. All right.
I mean, the density is 1,000 kilogram per meter.
Yes, the density
Meter
will
cube.
be 1,000 kilogram per meter cube. Exactly, 1,000. Okay, and the gravity is given to you, which is what? 9.80665 if you want. All right, and you have G,
Yes.
and you have the pressure, which is Pascal. Calculate H.
It's 85.
85 meters. How easy? Is 85 meters. I hope you got the idea. Good.
دكتور milliliter equal to meter cube.
What again?
Milliliter is equal to meter cubed.
Equal to milliliter. 1 meter cube. 1 meter cube. 1 meter cube equal to 10 to the power 6 milliliter. Or 1 meter cube equal to 10 to the power 3 liter. And the liter is equal to 10 to the power 3 milliliter. Clear?
Yes.
Good. A sample of argon gas that originally occupied 14.6 liter at 25 degrees C was heated to 50 at constant pressure. Which law you're going to use? Quickly.
V1 over T1 is equal V2 over T2.
What's the name of this law?
Charles' law.
Charles' law, exactly. I hope, and you can do it very easily. This is the answer. I'm not going to spend much time. Okay, if we combine 3 liters of NO and 2 liters of O2, we're going to get into 2NO2 gas. I want you to tell me if we know that this is 3 liter and this is 2 liter. According to Avogadro's law, how many liters we're going to get here? In 2NO2.
2.
No, not 2.
5.
8.
3 liter.
Only 3 liters. Why?
Because so mole produce 3 liter.
So 3 will give you 3, but 2, if they take this 2 without the 3, how many moles are going to produce?
1.5.
4. No, this is 1 and this is 2. This means 4. But this means which one is the limiting reactant?
NO.
NO is limiting reactant. And according to Avogadro's law, we can calculate the number of liters from the chemical equation. So 3 liters will give me 3 liters of this one. Is this clear?
دكتور كيف حددت الليميتنج رياكتنت؟
لأنه you have to think, if I have, this is NO plus O2 to give me 2NO2. If I say, I'm not going to care about the oxygen now. If I have 2 liters of this one, how many liters of this one I'm going to produce?
2 liters.
Because it's the same number, I will have 2 liters. How about if I produce, I have 5 liters. How many liters I'm going to produce?
5 liters.
Clear? Now, I will erase this. If I take the other one, if I have 1 liter of this one, how many liters I'm going to produce here?
2.
Yes, 2 liters. How about if I have 5 liters?
10 liters.
10
liters, because the relation is 2 to 1. Clear? Now, if I have mixture of the two, let's assume that again I have 5 liters of this one. This is supposed to give me 10 liters, and I have also 5 liters of this one. How many liters I'm actually going to get?
5.
5.
What?
Because the limiting reactant is the oxygen.
Because now this one is limiting reactant. This one, if this is by itself, it should give me 10 liters. But since it is with this one, this is limiting. This will react with only 2.5 liters of this one and give me 5 liters, and 2.5 will be extra, not used. Excess. Is this clear?
Doctor, how I can find
Yes.
the limiting reactant?
Okay, just a second. Now, let's go back to our example. If I have 3 of this one and 2 of this one, I'm going to get only 3. How much excess O2 I'm going to have? Excess, mean extra.
1.
No?
1.5.
1.5.
mean 0.5.
0.5. Exactly. 0.5 liter extra. Again, I know that 2 react with 1. 3 will need how much? 1.5. And will produce 3. And 0.5 will be excess, not used. Is this clear, ya shabab?
Yes.
Yes.
I hope it's clear. Good. Because, okay. Again, I'm not going to go over this problem. You can see it later on. Okay. Yes. Calculate the density of CO2 at room temperature at 25 degrees C and 1 atmospheric pressure. Can you calculate the density? Which law you're going to use?
Yes. PV is equal DRT. BM is equal DRT.
DRT? No. It's PV equal to nRT, but instead of N, I will write mass over molar mass, which is number of moles. We calculate it by mass over molar mass, RT. If I want density, which is mass over volume, P times the molar mass equal to what? Mass
Density
over volume, RT, or equal to density times RT, P times M. So what's density?
PM over RT.
PM over RT.
P, molar mass over RT, as simple as that. Go ahead, calculate the density of CO2. You have all the information.
1.8.
1.8.
1.8, exactly. It is 1.8 gram per liter. Why? Because the pressure is 1 atmosphere, molar mass is 44.01, This is 1, and R is 0.0821, and temperature is 25 plus 273.15. I hope you have to memorize this equation, or at least you have to know how to derive it. Clear يا شباب? Good.
Yes, clear.
Good. Okay. Now, again, calcium metal react with water to produce hydrogen gas like this. Determine the mass of H2 gas produced at 25 degrees C and 0.967 atmosphere when 525 milliliter of the gas is collected over water. How can you do that? Again, when you collect gas over water, you have to take care of the pressure of hydrogen only equal to the total pressure minus the pressure of what? Of water. Clear? This is the total pressure, and this is the pressure of the water, which is 20. This will be given to you, not you don't have to think about it. The pressure of the water is 23.8. I will change it to atmosphere. Now, what's the pressure of hydrogen only? It's the difference between this one and this one. All right, what is it? Give me answer.
It's 0.9357.
9356 atmosphere. Good. Now you have the pressure of only the hydrogen, the volume, and the temperature. What can you calculate? N. As simple as that. PV over RT. How easy? But don't forget to subtract the pressure of the of water if you are collecting things over water. Clear يا شباب?
Clear.
Good. Let's solve this question very quickly. What is the URMS of chlorine gas at 30 degrees C? Go ahead and calculate it. Which law you're going to use?
Square root of 3 RT over the molar mass.
Square root of 3 RT over the molar mass. But the molar mass must be what?
In kilogram.
In kilogram. So what's the mass of chlorine gas?
Uh, 35.5.
35.45. Is this the correct answer?
No, divide by 1000.
Multiply by 2. Chlorine gas is Cl2, not Cl. This is Cl only. Chlorine gas Cl2. Clear? So the mass is 70.9, is it? 70.90. Clear يا شباب? And this one times 10 to the power minus 3 kilogram. Which R we're going to use here?
8.31.
Exactly 8.31, because I want it in joule, not the liter atmosphere. Good. Calculate now the speed in you have the temperature, everything you have. You have R, this is R, and this is T, and this is the mass in kilogram already. Calculate what's URMS. Give me answer.
It's 326.5.
326.5 exactly. Clear يا شباب?
Doctor,
Yes.
Yes.
can you repeat why you choose R equal 8.31?
Because there is I need it in joule. When we talk about energy, this is energy. When it's in energy, I need it in joule. When I want it for volume, I use liter atmosphere. R with the liter atmosphere.
Okay.
Okay, good. Now, determine how much faster helium gas. Now, what's helium gas? HE.
HE.
Is there two?
No.
No. Okay. Moves on average compared to carbon dioxide. Carbon dioxide is O2. So what's the question is asking? Move. This means what?
velocity.
U of 1 or okay, U of helium compared to U of CO2. Okay, what's the U of helium over the U of or speed of CO2? What's the equation that we're going to use?
It's square root of molar mass of CO2 over molar mass of HE.
Yes, CO2 divided by the molar mass of helium. Clear يا شباب?
Yes.
Is this unit has to be kilogram or gram or what? It doesn't matter.
Doesn't matter.
Why? Because the unit will cancel with each other. Clear? Okay.
Yes.
Clear. Before we solve the problem, do you expect the answer for this one to be less than 1 or greater than 1?
Greater than 1.
Why?
Greater.
Why? Because the smaller the molecule, the faster. So helium is much faster than CO2. Why? Because it's less weight. Clear يا شباب?
Clear.
Then the answer must be greater than 1. Greater than 1. If you get the answer less than 1, this means you are making mistake. And give me the answer. What will be the answer?
3.33.
3.32.
Good. Yes, this is the correct answer. And I know before I solve it, this must be greater than 1. Okay, clear يا شباب?
Clear.
So let's solve this one. Now, determine the time required for helium gas to fuse, provided that it takes 72 minutes for the same amount of carbon dioxide to fuse at the same temperature. So now the time of helium, I don't know, but I know the time of CO2, which is equal to 72 minutes. What's the time for helium for the same amount of gas? Which equation should I use?
The same equation for.
Is it the same equation like last time?
Yes.
No, actually, we have to reverse the thing now. This is helium up and molar mass of CO2 down. Clear يا شباب؟ ليش؟ لأنه this is the time. Now again, before we solve the problem, which one will take less time to fuse? Helium or CO2? Less time.
Helium.
Faster.
Helium.
Huh? Helium will take less time. See, when we talk about the rate, or the speed is meter over second. Clear? So when we talk about the speed, then we keep it like this, reversed. I mean, this is helium up, CO2 down. This CO2 up, helium down. We reverse the gases. But when we talk about the time, we keep them the same thing, same time, I mean, same order. Helium up and CO2 time. because now we're doing 1/2 we need the second the time. And now tell me how much will helium will take, and I know the answer before I take more time for carbon dioxide to fuse than to helium. Since it takes 72 minutes for CO2, how much time will it take for helium?
Less than
Less
72.
than 72. Give me the answer.
It's 6.5.
Exactly, 6.5 minutes. Is this clear? I hope so. Good.
If he say the distance,
What?
if he say the distance instead of time,
Distance?
yes.
Yeah, distance keep the same, like speed.
Okay.
Okay. Yes, if it's distance, you keep the same. If it is time only, you put it in the same order. Helium up, CO2 down, CO2 down. If it's time, but if it is distance or speed or rate, you reverse the ratio here. I hope it's clear. With this, we finish chapter 10. Let's go to chapter 5. And the first question says, calculate the overall change in internal energy. What law you're going to use here? For a system that absorb, what's this? Absorb 188 joule. This is Q.
Q
Yeah, and is it going to be plus or minus?
plus.
Why?
plus
Absorbs.
Absorb 188 joule. And does, what's this?
Work.
works
And is it
negative.
Negative.
negative? Because it does the work. So what's delta U?
Plus 47.
Q plus W. And you put them, and the answer is 47 exactly. Good. Next, consider the reaction. This one to give you this heat. At certain temperature, if the increase in volume is 32.7 liter against an external pressure of 1 atmosphere, calculate delta U. So I give you here delta H, and I want to calculate delta U. I know delta U is equal to what? Equal to, yes, actually, delta U equal to delta H plus delta W, because H, if this is same volume, it will be equal to, what is it? And that will be similar to heat. And delta W will be equal to what? Delta H plus P or minus P delta V. Work is P delta V. Is this clear? So can you calculate what's delta U? What's P delta V? Increase in volume by 32.7. What's this 32.7?
Delta V.
Delta V. And the pressure is 1. So what is the P delta V?
32.7 multiplied by.
That's it. Okay, why what?
Times by 101.3.
Right. Now, the unit here is liter atmosphere. I want to change it to joule by multiply by 101.3 to make it joule. And delta H is given to me in kilojoule, so I can say it's 483.6. times 10 to the power 3 joule, and I can do my calculation. Or change it to that, change it to kilojoule. Clear? This is the answer.
Doctor?
دكتور
Yes.
How to get
وش
the
الفرق
H?
بين ال H
H and what?
How did you get delta H with the delta H? Because
Q.
in the equation it's Q, it's not delta H.
Yeah. Q and delta H. احنا زي ما قلنا الدلتا H إذا كان constant pressure تصير الدلتا H تساوي exactly QP. We took this in the course. And so this is constant pressure. So delta H in this case equal to QP. Q. For this case, delta U will be equal to, instead of Q, we will say delta H because it's QP at constant pressure. Clear? We took this as part of the course.
Yes.
Okay, good. Let's solve this problem. Given this thermochemical reaction, how much heat I'm going to need for 75 gram of glucose? What should I do? I have 75.0 gram C6H12O6. What's the first step I should do?
Convert to mole.
Convert to mole.
1 mole C6H12O6 is equal to 180.2 gram. Let's give it to you here. Good. What's the next step? Each 2803 kilojoule will need how many moles of C6H6? One mole. It's one. Clear? If I use it for CO2, I should put it for 6. But here I will put 1 mole C6H12O6. And that's it. You have the answer. What's the answer?
1166.6.
That's good. Next, determine the amount of heat in kilojoule given when 1.26 times 10 to the power 4 gram NO2 are produced according to the following equation. Now again, 1.26 times 10 to the power 4 gram NO2. What's the first step I should do?
Convert to mole.
convert to mole.
NO2, what's the number of mole?
48.
6.01, isn't it? Gram NO2. Please calculate it. I hope I didn't make a mistake. Is it correct?
Yes, yes.
Okay, I hope so. Good. Now, the heat is 114.6 kilojoule. What should I write down?
2 mole.
2 mole.
And now you write 2 mole in O2. Why? Because this is with 2 mole. And now you have the final answer. What's the answer? Quickly.
15695.
Good. Okay. Okay. 1.1375 gram sample of solid magnesium, which is what? Mg, is burned in constant volume bomb calorimeter that has a heat capacity of 3024 joule per degree C. The temperature increased by 1.126 degrees C. Calculate the heat given off by burning Mg in kilojoule per gram and kilojoule per mole. So which equation are we going to use?
Q equal C capital multiplied by delta T.
Exactly. What's delta T?
100 and 1000.
Already given to you. Oh,
Okay.
it's this one. As is. Okay. What's C?
3000.
3024.
Exactly. So you multiply this 2 and you have the answer. But this is for per what?
Per mole.
No, per
gram.
Per joule.
0.1375 gram mg. This is the heat from this amount. What's the answer here, by the way? Multiply this by this only.
3405.
3405.
Only without nothing.
That's it? Good.
Yeah.
Can you make it per gram? Divide by this number.
It will be 2476.
2476.
3.8.
Exactly. Clear? And can you do it per mole? This is per
Is it joule
Divide by
or
mass.
now you multiplied 24 point, what's the mass of mg?
24.31.
31 gram mg. And if you multiply it by 24.31, you'll get it per mole. That's it. Is this clear? Good. Okay. Now we have this one, a reaction in which we have this amount of HCl. How many moles? If you have milliliter and molarity, can you calculate the number of moles?
Yes.
Yes.
Give me answer. Two times this number. That's all.
Do we have to change it to liter?
Of course, you have to change it to liter. That's why it is actually, to be exact, it's 0.2 liter times 0.862.
It's 0.174.
Now this is mole what? Cl minus, HCl I mean. How many mole H plus? Same number of mole H plus. Clear? Now we have 2 of this one times 0.431 mole BaOH2. How many moles this one? Again, multiply 0.2 a liter times 0.431. What's the answer?
It's 0.0862.
Now, this is what? Mole BaOH2. What's the molarity of OH minus only?
Divided by 2?
No, multiplied by 2. Each mole of this one will give you 2 moles OH minus. So you multiply it by 2. And what's the answer? Clear? And so, is there a limiting reactant? Hello?
They have the same, or they're both limited reactant?
What's this mean? We have no limiting
This
reactant.
reaction will react completely.
Exactly. Okay, we want to know how much heat when we mix these two together. The heat of neutralization is minus 56.2 kilojoule per mole. So what will be the heat of the reaction?
times mole by the minus 56.2.
Q equals what? Q equals what? 0.174 mole. Which one should I take? The H plus or H minus? Same thing. Clear? And the heat is 56.2 kilojoule per mole. Mole will go with mole, and you have the Q. What's Q?
It's 9.689 kilojoule.
9 point what?
689.
689 kilojoule, exactly. That is the heat, Q. This Q is equal to MST. You know this? What's this? Mass times specific heat times temperature. Clear? What's the mass of the water, of the liquid now?
Add the moles, add the letters, and then times it by the density
Yes.
of the water.
What's the density of water?
1.
1. And so you have 0.2 and 0.2 liter, which is 0.4 liter or 400 milliliter. So what's the mass? $400 gram. Specific heat of water is given to you in the periodic table, but what is it?
4.18.
4.184 times delta T, not T, but delta T. So calculate delta T.
دكتور كيف جبنا ال 400 جرام؟
400 جرام 0.2 لتر هنا و 0.2 لتر هنا، يعني 0.4 لتر، صح؟ يعني 400 ملليلتر، والدنسيتي جرام بر لتر، so it's 400 جرام. كلير؟
كلير.
دكتور.
يس.
اقدر اطلع الماس عن طريق المول؟
الماس عن طريق المول؟ طبعا.
احول.
وين المول؟ انت عندك المول.
هذا 0.17.
ايه صح، تقدر، بس لا، بس هذا من اللي ينتج عن التفاعل، بس هو معمول في كميه كبيره من المي. هذا بيزيد كميه المي، بس هذا قليله جدا بالنسبه للميه الاصليه يعني. اوكي، هذا التفاعل هذا بيزيد كميه الميه، هذا من جهه الميه من التفاعل فقط.
يعني نحسب عن طريق الليتر بعدين الدنسيتي.
هذا له علاقه بالتفاعل. احنا اللي حسبنا، انت قاعد تعمل التفاعل في وسط الميه، يعني التفاعل صار في وسط الميه اللي احنا مسوي فيها التفاعل هي 400، ولكن التفاعل كميته بسيطه تفاعل مع بعضها يعني.
كلير دكتور.
Okay, good. All right. Calculate what's delta T. You have 400 gram, the density, and you have the heat, which is this one. What's delta T?
It's 5.79.
Exactly. And so what will be the T final? What should you do? Add this number.
Subtract.
No, add, because the heat, of course. Minus. What does minus mean? The heat will go from the reaction to the water. So what will happen to the water? The temperature will increase. Clear يا شباب؟ يعني الآن your system is the reaction itself, and the surrounding is the water. The 400 water here, milliliter of water or 400 gram of water is the surrounding. This is minus, this means the heat goes from the reaction to the water. And the temperature of the water will increase. It was 20.48, now it is 26.27. Clear يا شباب? I hope so. Good. Okay. Let's go to something else. Now, this is Hess law. You know what's Hess law?
Yes.
Hess law.
Yes. Yes, doctor.
What's Hess law?
الدلتا اتش حقت التفاعل تساوي الدلتا اتش حقت كل ستيب من التفاعل او كل بارت من التفاعل.
After you play with it and make it equal to the last equation. Exactly. طيب التفاعل اللي يبغاه standard clean. What's the standard? Can you write equation for the standard enthalpy of formation of acetylene?
Yes.
Okay, give me the equation.
2C. Okay. What?
Yeah, 2C.
2C plus H2.
H2 gas, and this is graphite to give you C2H2. That's it. Can you, from this reaction, do this reaction? Make this reaction. What should you do? The first equation, you must multiply it by what?
2.
By 2 and keep it as it is. So we'll multiply this also by 2. Clear? How about the second equation? Multiply by 1 and keep it as it is.
Yep.
Right? And the last equation?
Yeah. Divided by 2.
Divided by 2 and
multiply
reverse it.
minus half. Tell me why minus and half?
To reverse it.
Because we
Reverse
should
the-
reverse.
Exactly. I will reverse it and divide by 2. Exactly. And that's why I put minus half. Now, do it for everyone. Do whatever I wrote here in your, try to make the equations. And see if everything is cancelling.
Is it 226.6?
Exactly. Delta H equal to 226.6 kilojoule. How easy?
Very easy.
Easy.
So, good. Let's try this one. Okay, I want now determine the enthalpy change for gases reaction of sulfur dioxide with ozone to form sulfur trioxide. So I gave you only word. What are you going to do here? You're going to react sulfur dioxide, which is SO2 gas, with ozone O3 to form sulfur trioxide, SO3. Okay, so is this balanced?
No.
No. I can multiply this by 3 and this one by 3, and that's it. I'm done. Am I correct?
Yes.
Yes.
Good. All right. So what should I do with the first? Oh, yes. What should I do with the first equation?
Reverse it.
Reverse it. Only reverse it?
Multiply by half.
I will multiply by minus, because to reverse it, and then what?
3 over 2.
Over 2. Same thing here, minus 3 over 2. I multiply it by minus. Why the minus? To reverse it. Clear? And the 2 and the 3 over 2 to make it, I want this one to be 3, not 2. I want it to be 3 like this one. Clear? How about the second equation? What should I do with it?
Multiply by half.
Half?
Multiply by half.
No, 1. Why 1/2? I want to keep 3 or 3. 3 or 3 here. Clear, ya shabab?
Clear.
I did not do anything because I want to keep this one as the product here. Okay? Now, I have here, okay, do these two equations first. So, you have here this one 2 over 3. Okay, how about the last equation?
Multiply by 1.
Reverse it or keep it or what?
Keep it.
Yes, keep it as it is, exactly. Why? Because 2 of this one will go with this one, and 2 will go with the 1 here, and I have only 1, and this is what I want. Now, do it yourself. Multiply the first one by minus 3 over 2. This means reverse it, and multiply everything by 3 over 2. This one keep as it is. This one keep as it is.
It will be minus
438.63.
Are you sure you cancelled everything correct?
It will be minus 146.2.
No, it should be more than that.
Minus 438.
Exactly. 438 and what?
0.63.
0.63 maybe. Okay, I like this. Now, if I want SO2 plus 1/3 O3 to give me SO3, what will be the heat? You divide this by what?
By 3.
By 3, and then you will get minus 146.2 kilojoule. Clear?
Clear.
I hope so. Good. Yes, this is the correct answer. Good. Now, calculate delta H. What do we call these? What's this? Can you read this?
Heat of fusion.
This is called what? Standard heat of what?
Formation.
Formation. Okay. What's the law to calculate delta H from standard heat formation? Yes?
Formation for the reactant.
Exactly. Now, what's the heat of formation Br minus? It's given to you here. What's the heat of formation HBr? It's given to you here. What's the heat of formation of H plus?
0.
0.
0.
0. This is the only ion that have heat formation equal to 0. Only H plus. All the other ions has value, but H plus is 0. So what's delta H for this reaction? Give me the answer.
It's minus 84.7.
Yes. It's actually the product, you keep it as it is, so it's 120.9 minus times minus, because this is minus product, times minus 36.2 for the reactant, and the answer is 84.7. How easy? Good. Very quickly, solve this question. Before you start, what's the heat of formation of aluminum?
0.
0. If it's element by itself, it's 0. How about iron?
0.
0.
Also 0. So what's the heat of reaction? By the way, what's this RXN?
Reaction.
Reaction. Good. What's the answer? Quickly. You have to multiply what by what?
Minus 3016.
Yeah, but what? You have to multiply what? This number what?
4 times
this number without change, and this one
3.
3, but you have to change sign or minus 3 if you want to multiply it, and this is the answer. So what's the final answer?
Minus 3316.
I hope this is also clear. All right. Now, very quickly, chapter 6. Calculate the wavelength in nanometer of a photon emitted when an electron transient from n equal to 4 to n equal to 2. What's the equation that you're going to use?
1 over lambda.
Yes, 1 over lambda equal to what?
R infinity.
H times what?
1 over n.
Over n final square.
Final square minus 1 over
n
square. Okay, RH will be given to you. If you have periodic table, it's available for you in the periodic table, but let me give it to you here. It's actually 1.097 times 10 to the power 7 meter minus 1. So if you use lambda, use the meter minus 1. But if you use delta E, we can do the same equation with delta E equal to what? RH over 1n final square minus 1 initial square. But which RH we're going to use here? The one with joule. Be careful. Okay, so this is given to you now, RH. Calculate what's lambda.
.86 times 10 to the power minus 7.
4.86 times 10 to the power minus 7 meter, exactly. This is, of course, finals 2, and this is 4 square, and that's it. And you can solve it very easily. I hope this is clear. Good, it is. Okay. What's Palmer series? Do you know what's Palmer series? In the hydrogen atom, when the transition comes from higher state to n equal to 2, this is called Palmer series. Anything that comes to n equal to 2 is called Palmer series. But in this question, he just put the information. Occur at 656.3 nanometer. So you're given lambda, which is equal to 656.3 nanometer. What's the energy difference between the two energy levels? What's delta E if you are given lambda? What's the law that you're going to do?
H nu.
H. What?
HC over lambda.
Exactly. Or HC over lambda. Exactly. And the lambda must be changed to what?
meter.
Meter. H, you have it in the periodic table. It's 6.626 times 10 to the power minus 34. The speed of light is also given to you. It's about 3, but it's exactly 2.998 times 10 to the power 8 meter per second. And the 656.3 times 10 to the power minus 9 to make it meter. I multiply by simply 10 to the power minus 9. Okay, what's the energy?
3.03 times 10 to the power minus 19.
Joule per what? Per particle. Per particle. If I want it per mole, what should I do?
Multiply by Avogadro number.
Exactly, multiply by Avogadro's number and you'll get it per mole. Clear يا شباب? Good. Next. Calculate the energy required to ionize hydrogen. What does ionize hydrogen? This means take it from H gas to H plus gas plus electron. This means the electron is completely gone from the hydrogen. So we're going also to apply the same rule, which is that now I want delta E, which is energy, is equal to RH times when the hydrogen is in the ground state, what's N?
Equal to 1.
Exactly. So initially it was 1 over 1 square, that's initial. What's the final? Since it's completely gone, it went to infinity square. Clear? So what's delta E? Now, which RH I'm going to use? I ask you for energy. Which RH you're going to use?
That has joule.
Joule. And it's in your periodic table, it's available as 2.178 times 10 to the power minus 18 joule. Okay, now what's then delta E? What's 1 over infinity equal to what?
0.
And 1 over 1?
1.
What's the final answer then?
2.
Delta E is the same because this one will be 1, all of it. Can you see that?
دكتور.
Yes.
بالقانون هذا ليه حطينا R equal minus؟ مكتوب بالقانون minus R.
هي minus R أصلا. minus R.
لا بس في قوانين ثانية هي مكتوبة بالR بس بدون minus.
لا مش مهم لأن زي ما قلنا هو لازم تعرف إنه لما الإلكترون يكون تحت ويطلع فوق you're going to put energy. The final answer should be positive. But if the electron goes down from higher energy to lower energy, the answer should be negative. Well, don't worry about the minus here. Don't worry about it much.
دكتور 1 over infinity equal to 0.
نعم.
1 over infinity square equal to 0.
Of course. 1 over infinity is 0, and 1 over 1 is 1. So the whole thing is 1 only. Good. Okay. So this is the solution for it. Okay. An electron of hydrogen atom make transition from an energy state to principal quantum number n equal to I to n equal to 1. If the photon emit has a wavelength of 94.9 nanometer, what's the Ni? Can you do this problem? Which law you're going to use? 1 over lambda equal to what?
R
H over 1 over
N final minus تكعيب تربيع
تربيع, and this is the final, n equal to 1. What's the initial?
Ni تربيع.
Which is, I will keep it as it is because I don't know what is it. All right. Now, R again, which R I'm going to use?
1.097.
Exactly. Times 10 to the power 7 in minus 1. Go ahead. You have this lambda is available for you, which is 94.9. Don't forget to change it to what?
Meter.
Meter. Tell me what's the N final or initial. So
It will be 5.
Exactly 5. Who got it? 5.
Me.
Initial is 5. You have to know how to find it. Clear يا شباب? Good. All right. Calculate the wavelength associated with a beam of neutrons at 7.00 times 10 to the power 2 meter per second. Mass of the neutron is 1.675 times 10 to the power minus 27 kilogram. Which law we're going to calculate here or to use?
De Broglie.
De Broglie, exactly. So what's the law of De Broglie?
Lambda equal H over mv.
Lambda H over m v or u. We use u in our book. Okay, what's m?
1.675.
That's m, and it's already kilogram, which is good. It must be kilogram. What's the speed u?
700.
7 times 10 to the power 2 meter per second. And what's h?
6.6.
You don't have to memorize. It's available in the book and the periodic table. But what do you call it? What?
A Planck constant.
Constant. I would say this Planck's constant, which is joule second per particle. Okay. What's lambda? Yes.
Uh, 5.651.
Yes.
Multiply by 10 minus 10.
Minus 10, exactly. So it is 0.561. What did you say? 0.561 or 5?
5.651 multiplied by 10 سالب 10.
And I say the answer is 0.5651 nanometer. Can you see how did I change it? Yes, you're right when you said 5.651 times 10 to the power minus 10 meter, or 5.651 times 10 to the power minus 1 nanometer. Why? Because you multiply 10 to the power plus 9 to make it nanometer. And now I will change it to 0.565 nanometer. Clear يا شباب?
Clear.
Good. Okay. The error in the speed of thermal neutrons is 0.2 kilometer per second. What's the minimum uncertainty in position of the thermal neutron? The mass of the neutron is this one. Which equation we're going to use?
Heisenberg.
Yes, what's Heisenberg equation?
Delta X multiply delta T.
Delta X multiplied by mass delta V, delta U, is equal to what?
H over 4 pi.
Exactly, you have to memorize it. H over 4 pi. What's the mass? This is the mass already in kilogram, which is good. How about the speed? Is this the right speed?
We should
change it to what?
Meter per second.
Yes, because it's not kilometer, and its unit, it must be meter per second. Exactly. Can you calculate delta X? Quickly, I need an answer.
It's 1.574 multiplied by 10 power of minus 11.
Exactly. I hope you got it, but it is available here also. In photoelectric experiment, but it was done by using laser at 450 nanometer, which is blue light, and the laser at 560 nanometer, which is called, it is yellow light, on a clean metal surface, and measuring the number of kinetic energy of the ejected electrons. Which light would generate more electrons? Which light will give you more electrons? Is it the blue or the yellow?
Blue.
Why?
Blue.
Why?
Blue.
Because less wavelength, greater.
Exactly. Don't forget that the energy is equal to hc over lambda. So the smaller, this one is smaller than this one. So which one has more energy? The blue or the yellow?
The blue.
The blue more energy, so it will give you more electrons. And when it hits the metal, which one will have greater kinetic energy? Is it the blue or the yellow?
The blue.
Also, the blue will give you greater energy. That's so the blue laser is at higher energy than yellow laser. It will eject more electrons and have higher speed. Good. Let's solve this problem. And in this one, I gave you the equation. In the exam, we are not going to give you this equation. What's this equation called? This one you have to memorize, but I give it to you to solve the problem. What's this equation called?
هذه حقت أينشتاين.
Einstein. What's the name?
Photoelectric.
Photoelectric equation. Photoelectric equation by Einstein. Okay, what's H nu?
Energy.
Of light. What's W?
No,
the
the energy needed to take off the electron.
Which is called what?
kinetic energy.
No, it's not kinetic.
Finding energy.
Finding energy. And the last thing is the kinetic energy, which is half mu squared, which is this one. Clear? Okay. Somebody, he used the frequency nu of the light on the metal. W is the energy needed to remove the electron from the metal. And me is the mass of the electron, and U are the mass and the speed of the ejected electron, respectively. In an experiment, a student found that the maximum wavelength required to take the dislodge, to take the electron away, is 351 nanometer. This one, this energy, we call it threshold energy. What's threshold? The maximum wavelength or the minimum energy required to take the electron away. So this one is the minimum energy required to take the electron. So this 300 nanometer, the light, is equal to what in energy? Equal to the binding energy. Because what's the meaning of dislodge? What's the meaning of dislodge? Take away.
Take away.
يعني يدوب يشيل الإلكترون. The 351 is the energy required to take the electron. So can you calculate W? This is the threshold energy, which is W. Can you calculate it? It's C over what? Low?
Over lambda.
Well, calculate it. Give me an answer.
It's 5.659.
Yes.
Multiplied by 10 power of minus 19.
19 joule. Very good. Now, we use another, calculate the velocity, which is U, of the ejected electron when the student employ light, which is more energy than 351, which is 313. So, if you are given the 313, what can you calculate? You calculate what? H nu, which is equal to what? HC over lambda. And now calculate what's this equal to. Use the 313 now.
It's 6.34. Multiplied by 10 power of minus 19.
Minus 19. Very good. Yes, I agree. Good. Now, the mass of the electron is given to you here. Can you calculate the speed of the electron? Look at the equation and do it.
It will be 3.884 multiplied by 10 power of 5.
Yes, you're right. I hope you got it. And you have to take the difference to calculate U. We calculated W. We calculated H nu. So I subtract these two from each other and they can calculate U. And this is the correct answer. It is 3.884 times 10 to the power 5 meter per second. Okay. Now, very quickly, indicate which of the following sets of quantum number is unacceptable. The first one, A, is it acceptable or not acceptable?
Not.
Now this one, of course, don't. This is N, this is L, this is ML, and this is MS. The first one, A, is it correct or wrong?
Wrong.
Wrong. The L should be less than N.
No, the maximum L that you can get with N is what? N minus 1. So you cannot get 1 with 1. So the maximum that you can get here is what? 0. And that's why this is wrong. The whole thing is wrong. Okay, good. Second one, is it correct or not correct? B.
Not correct.
Why?
ML should be 0.
Yes, ML can take from minus L to plus L. So if this is 0, this cannot be other than 0 because it will be minus 0 to plus 0, which is 0. And so this is also wrong. How about third one, C?
The same.
The same.
Also wrong.
It cannot be other than 0, exactly. How about D?
Correct.
Correct.
It is correct, very good. How about E?
Correct.
Wrong because
No, wrong.
MS should
Wrong.
be
MS.
half or
Exactly, plus half or minus half, you cannot have 1. Clear? Good. Quick question also. Which of these electron configurations is wrong for ground state? Is this correct? What's the structure of aluminum?
1s2.
1s2, 2s2, 2p,
6.
6, 3s2, 3p,
1.
1. That's aluminum, exactly. Is this the correct structure?
No.
Why? We took what? 2 electrons from what?
From 3p.
2p, and we put it in where?
3s.
3p.
3p, okay, 3p.
3p we put, because is this structure is acceptable or not acceptable? Is it correct? It is correct, but it's not the ground state. It is what?
Excited.
Excited state. This is the ground state. Clear يا شباب? Okay. How about boron?
Wrong.
Why wrong?
Because it's 5 only.
Only 5. And what should I do to make it right?
2p1.
1, exactly. How about F?
It's 2p5.
2p5.
Correct or wrong?
Wrong.
Wrong.
Why?
2p5. Because it's 9.
Exactly. That's 6. Clear يا شباب؟
دكتور سؤال الحين، كيف أفرق بين الإكسترا excited state and grounding state من التوزيع الإلكتروني؟
إذا التوزيع صحيح وعدد الإلكترونات مضبوط، كم عدد الإلكترونات هنا في الألمنيوم؟
العدد الأصلي 13.
13 واللي موجود هنا في الشكل احسبهم 2 2 10 12
13
10 12 13 مضبوط ولا مش مضبوط؟
مضبوط.
طيب وهنا
نفس 13
وما في شيء، البي ما فيها اكثر من 6، لو في اكثر من 6 يطلع خطا، بس هذا 6 وهذا صار 4 بدل، فاي شيء 13 ارقام وكل شيء في مكانه يعتبر اكسايتد ستيت.
اوكي
good. Next. Unpaired electron. ايش معناته unpaired electron؟ يعني في الغرفة what؟
فرد إلكترون واحد.
We have one electron في الغرفة الواحدة. Okay. Let's take something like boron. كم عدد الإلكترونات في البورون؟
5.
5. What's the structure? 1s2, 2s2, 2p1. Is it going to be? Is there any unpaired electron?
Yes.
Why? Because with 2p there is only one electron. So there is one unpaired electron. خلونا نروح الكربون 6. ايش الشكل حقه؟ 1s2, 2s2, 2p2. Is there going to be any unpaired electron?
Yes.
Why? Everything 2, 2, 2.
Because we take one pair, the second room.
Hans rule.
Hans rule, exactly. Hans rule, and we take it. We take it to the second room, and this way there will be. How many unpaired electrons do we have in the first one?
One.
How many unpaired electrons we have here?
Two.
Two. You have to be careful with this. Good. Okay, if we have this electronic structure, what's this element?
Magnesium.
It's magnesium. Right. I want to write all the quantum numbers for an electron. I'll take one electron in 2s, for example. 2s, and I have two electrons. I will take this electron, not this electron. I'll take this electron. What are the 4 quantum numbers? Can you tell me what is n?
2.
2. What's L?
0.
1 and
0.
Can we say 1?
No, 1B.
No, it's 0.
0.
Exactly. S is always 0. What's ML?
0.
0.
Other than 0. Good. And then what's MS?
Positive half.
Okay, let's take another electron in the other room, which is, in this case, we have 2p6. 1, 2, 3, 4, 5, 6, 2p. Okay, I'll take this electron and concentrate with me now. What's N?
2.
2. What's L?
1.
1. This is because it's P. What's ML?
Positive 1.
It could be positive 1, or if I put positive 1, this is 0, this is minus 1, so this is, yes, positive 1. And then what's ML? MS?
Minus half.
Minus half. Why minus half?
Because it's down.
This one I decide plus half, and this one, since it is down, it must be minus half. Exactly. Clear يا شباب? طيب, last slide, and I'll stop here. Which of the following species has the greatest number of unpaired electrons? S plus, S, or S minus? Which one has the highest number of unpaired electrons?
Positive.
First, let's write the electronic structure of S. How many electrons do you have for S?
16.
16. Yeah, it is 16. Okay, which is what? 1s2, 2s2, 2p6, 3s2, 3p4. So how many unpaired electrons do you have for S?
2.
Why?
Because one room we will fill it.
We'll have it like this: 1, 2, 3, and 4. And that's why, yes, there is 2. How many unpaired electron?
2.
2.
How about S minus?
1.
Why?
Because we add
because
add 1 electron. How about S plus?
3.
3.
Why?
Because we lose 1 electron.
We take off 1 electron.
All right, clear يا شباب?
Clear.
Okay, I'll stop here. The time is a lot now for me. And I gave you also some other questions. Review them and study them. They are interesting for you. Okay?
Okay, thank you so much.
I wish you all the best إن شاء الله. يلا مع السلامة.
مع السلامة، يعطيك العافية دكتور.